Do you feel the vibes?
Okay, so a polynomial inequality, right, is different from a polynomial equation. In a polynomial equation, we are looking for a value of x where the function equals 0. In a polynomial inequality, we are looking a range of values. We're looking for a range of values over which the polynomial is either positive or negative and so on. So the way polynomial inequalities are written, okay, is, for example, like this. F of x is less than 0, not equal to anymore, or greater than 0, or it could be less than or equal to 0, greater than or equal to 0. So let's think about let's think about what that means, right? So if f of x equals 0, that means at that point the y value is 0. If f of x is greater than 0, it means when you graph the function, the graph sits above the x-axis, right? So for example, take a look here. These are the x-intercepts. These are the values where f of x equals 0, right? Now, in this region, for example, right, in green, okay, all of the y values are greater than 0. So in that region, f of x is positive, right? Another region where f of x is positive is this. And the way in which we define the regions is the same way that we define the intervals where the graph is increasing or decreasing, using the x values. So in here, for example, f of x is greater than 0, where? From negative infinity to, what is this point here? 1, 2, 3, negative 4, right? And where else? From, what point is this? Negative 2 to 2, is that right? Okay. And then similarly, we can define the points where the graph is negative, and it's in this region and all of this region. Okay. Now, here we have a little bit of a situation. Okay. Because if we want to say where is the graph strictly negative, then look at this first region here. The graph f of x is less than 0 from negative 4 to negative 2. Why am I not including negative 4 and negative 2? Because how much? It's 0 there. It's not less than 0. It is 0. And so when I come here, the graph is negative, or f of x is negative from 2 to what? 3, 4, 5. 3, 4, 5. Right? At 5, it's 0. So 2 to 5 and 5 to infinity. Okay? As opposed to, had I said, identify the intervals where f of x is less than or equal to 0, then I would have said from negative 4 to negative 2 inclusive, and or from 2 to infinity in one interval. I don't split it up because it's, right, it meets all of the requirements there. Okay? All right, so how do we get to this if we have f of x? Well, you're going to first solve f of x, okay? You're going to pretend it's, f of x equals 0. You're going to plot the zeros on a number line to create a sign chart. I need to see this. And then you're gonna test values from each interval. Okay, so here we go. Let's do this first one. Okay, so x squared. Okay, so first of all, let's move everything to the same side. So we have x squared minus 8x plus 15 is less than or equal to 0. This is important, okay? This is the one we're going to refer to from now on. Okay, now, so basically factor this, right? Like pretend it's a regular equation. X minus 5, x minus 3 is equal to 0, or less than or equal to 0. So the zeros here are what? 5 and 3. Okay, so you have to create a sign chart. Put it on a number line. 3 and 5. Okay, now you're going to pick points from each of the regions. So let's start with, the leftmost region. I'm going to put 0. Okay, you can plug it in either like this first step or this one. I prefer to plug into this because it's less calculation. So when you plug 0 into the first parenthesis, you get 0 minus 5. That's a negative number. In the second parenthesis, you also get a negative number. That makes positive. So this is positive. Okay. Next, let's do 4. In the first parenthesis, I get negative. Then I get positive. So this is negative. Then let's do what? Let's do 6. Positive, 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 positive. Now, okay, you have to go back to the step where you compared your function to 0. That's this step here. You want your function to be less than or equal to 0. That's the negative region, so that's what I want. So my interval is from 3 to 5, closed interval. And because this is a polynomial function, there are no discontinuities here. We don't have much else to think about. We'll get to that later on when we get to the other ones. Okay, now, hang on. Don't switch the page yet. Let's talk about multiplicities. Okay? Okay. Take a look at each of these zeros. Look at the x equals 3 here. What factor did this come from? It came from x minus 3. What is the multiplicity there?
1.
Odd, right? And what about the 5? Odd. Okay, so take a look. All you really have to do is test one point. So suppose you tested the blue and you got positive. Because the border between the blue and the next one has an odd multiplicity, the sign has to switch. It is crazy. And now you're here. Because the border between the middle and the last one is an odd multiplicity, the sign has to switch. So really, you only have to do one. I only plug in a 0 into all my functions. I only ever plug in a 0, and then I just go left to right from there. That's crazy. We're going to do another one, and then I'm going to take questions. Okay. Okay, let's do that later. Okay. So here we go. Bring everything to the same side. X cubed minus 3x squared minus 22x plus 24 is greater than 0. We can't. This one doesn't. No.
Does that mean...
Okay, let's do P over Q. Okay, let's try them. Let's just try the first one. Yeah. Then you have like that many ever choices.
24.
Okay, so let's do this one now. 1, -3, -22, 24. Let's try this out. Let's see. Oh my God. Oh my God, there's hope. Yes. Okay. So now, x minus 1, x squared, minus 2x, minus 24 is greater than 0. factor some more. X minus 6, x plus 4, greater than 0. Okay, I can find my zeros. So here we go. What are they? Negative 4, 1, 6. Okay, take a look at what we're going to do. I'm just going to plug in 0. Okay, so we plug in 0 into this, and I get negative, negative, positive. That gives me positive. Correct? Okay, the 0 was from this region, so I'm going to put a positive there. Now, moving from the positive to the left region, right? The border is negative 4. What's the multiplicity? Odd or even? Odd, so this has to be negative. Now, moving from the positive to this region, what's the multiplicity at 1? Odd, so negative. Going to 6, what's the multiplicity? Positive. Right? Beautiful. Beautiful. I know, right? So this is it. Once you understand the math, you can use it to your advantage, right? Okay, let's write the answer first. So here we go. We want it to be greater than 0. So it's here and here, and those regions are from negative 4 to 1, open parentheses, and 6 to infinity. Okay, Evan, what is your question?
And is the reason why you're able to put the plus and minus continuously in that same order on the line is because I don't understand why you just put why you're saying that. Where are you starting from the equation that you're saying is the plus? What?
We put the plus here. Yeah. Going from here to this region, the border is negative 4. Mm-hmm. Negative 4 came from here. It has a multiplicity of 1, which is odd. When it's odd multiplicity, the sign is going to alternate going this way.
Got it. Okay.
And then it's going to alternate, and it's going to alternate. Okay, quickly.
So on a test, we can just put in 0 and it's still false.
Yes. Yes. Okay, so here we go. Look at this one. Does this factor? No. Well, this one you can also do quadratic formula.
Honestly, quadratic formula is way better here.
Okay. So now this one doesn't factor. So okay, so let's take a look. Okay. Let's put in some points anyway. At the 0, is it positive or negative? Positive. If I put in any positive number, do you see how it's going to stay positive? Yeah. What if you put in a negative number? Does it depend? What will it be if it's negative 1? What if you put negative 10? It's always going to be positive. The reason why it's always going to be positive is that's it.
How do you know this?
A number, okay, past 2, a number squared, like 5 squared, is always going to be much higher than 2 times that number. So you take negative 10, you square it, that's so much higher than 2 times negative 10. So the square is going to overpower the negative, right? And then that's past 2. But like at 1, there is the 3 here that overpowers anyway. So this is going to be positive anywhere. Now, if you are having trouble believing this, okay, okay, so why don't we do x squared plus 2x plus a number equals negative 3 plus a number. I'm going to do completing the square. So 1 goes here and 1 goes there. X plus 1 squared is equal to negative 2. X plus 1 is plus or minus I root 2. X equals negative 1 plus or minus I root 2. So it's an imaginary solution, right? So this doesn't even have an x-intercept. Like it doesn't cross the x-axis. So now, hang on. So the question now is, it's positive everywhere. The question now is, where is it negative, right? So it's no solution. Now take a look at this one. It's the same problem, but it's asking, where is it greater than or equal to 0? Everywhere. Because here it is. Okay, guys. Okay. So the question is, where is it greater than or equal to 0? Yes, it's never 0, but it's greater than 0 everywhere. So when we say or, remember, it only has to satisfy one of the two conditions. So greater than or equal to 0, whatever it satisfies is what you take. Okay, let's do this one. This one factors x plus 6 squared less than or equal to 0. So we have negative 6. Okay, put 0 in here, and you get positive. And look, at negative 6, there is a multiplicity of 2, so this one too is going to be positive. Now, how much is it at negative 6? 0. Okay, write that down so you can see it, right? Especially when the sign doesn't change. Sometimes we forget or we neglect that one point. Okay, so now let's see what this is asking. This is asking you, where is it less than or equal to 0? Just negative 6. It's not less than 0 anywhere, right? But it is equal to 0 at negative 6. So your solution will be, you can either say x equals negative 6, or you can say negative 6 like this. Now, before you switch the page, what if we had same problem, but less than 0? No solution. Okay, what if you had the same problem greater than 0? Everywhere but negative 6. So negative infinity to negative 6, negative 6 to infinity. And what if I said x plus 6 squared greater than or equal to 0? All real numbers. You see that? Same problem asked different ways. Okay? So these are, I love problems like this because there is little to no computation, but it really tests for, like, are you aware of what's happening? Are you alert of what's happening? And so on. Okay, now let's move on to rational inequalities. So before we do that though, let's go back to here. So when you look at a polynomial function, right, the place where the function can switch between positive and negative and vice versa is what? At what points? The zeros or the x-intercepts, okay? And that is the same for any function. At the zeros or the x-intercepts, there is always a possibility for the function to change sign, although it's not guaranteed, right? So like at this last x-intercept, it doesn't change sign, right? So like the statement is true, but the converse isn't true. Okay, now let's go to rational functions. The thing about rational inequalities is, just like polynomial inequalities, there is the possibility of a sign change at the 0, but in addition to that, it can also change sign at the asymptotes. Exciting, huh? I know. Sometimes you just can't contain yourself. And now you see why I explain it the way I do before, right? About like exiting and re-entering, because I'm from your future. I know where you're going. Okay. Yeah, I know. I also know what's going to be on your test, even scarier.
Have you already made it?
I do.
Do you know what's going to happen
Okay.
in the stock market?
Oh, no. I don't care much about.
Only with math.
I only care about math. I don't care about the stock market. Okay. So here we go. So here, we're going to find the zeros. And remember, for a rational function, you find the 0 by doing what? Yep. Look at you guys. I know. So on here, you're going to put negative 4 over 3. But in addition to this, you also have to put in the zeros of the denominator, the discontinuity. So the vertical asymptote. So x equals negative 2. Now, x equals negative 2 goes here. Now, do me a favor. This is also a good habit to have before you take calculus. At negative 2, the function is undefined. So let's put a little circle here to remind ourselves that the function doesn't exist there, because we're never allowed to do like negative infinity to negative 4 over 3, right? Because you have to break it there. Okay, now, same situation, but what you want to do is you want to plug it in to this, okay? So let's put 0. Okay, so 0, we're going to do like, okay, 3 times 0 plus 4. 0. Look at you. So this is positive over positive. So the way we do this is, look in the numerator, it's going to be positive over positive, so that's going to be positive. Okay, 4 over 3 has odd multiplicity, so it alternates. How about negative 2? Odd multiplicity, so it alternates. You see that? It's the same. It is crazy. So we want this to be greater than or equal to 0. So take a look. It's this region, negative infinity to negative 2. And even though it's greater than or equal to, can I close it at negative 2? No. Union, now here I can close it, negative 4 over 3 to infinity. Do you see that? Do you see how much action there is? Right? You just have to know all of these things. Hang on, let me do another one and then I'll take a question. Yeah. Okay, hang on. I'm going to do this one too and then I'm going to take a question. Okay. So here we go. This one, let us multiply both sides by x minus 2. It's the same as cross multiplying. But basically, it's going to be x squared minus x minus 11 less than or equal to 3 times x minus 2. So, x squared minus x minus 11 less than or equal to 3x minus 6. X squared minus 4x minus 5 less than or equal to 0. So what do we get here? X minus 5, x plus 1. Okay. Let's go on our number line. I'm going to put in negative 1, 5, and also what else? 2. But that's undefined. Okay, now, to plug in your values, you cannot plug it in to any step where your denominator has disappeared, because you've gotten rid of a discontinuity and a vertical asymptote. So it has to be the step before. However, remember, you're always going to have to compare to 0. So bring the 3 to this side. So I get x squared minus x minus 11 over x minus 2 minus 3 less than or equal to 0. Before anybody asks me, what if on the test we have a calculator and we don't have a calculator? I don't want that question. Okay? Okay? Okay. Let's go. So here we go. 0. 0 is in this region. We're going to plug it in here. And if I plug in 0, in the numerator here I get negative 11 over negative 2 minus 3. Positive or negative? That's positive. So 0 is here, positive. Okay, going to the left, crossing negative 1, what's the sign going to be? Negative. Because the multiplicity is odd. How about at 2? When I cross the 2, negative, and then the positive. Okay, so we need this to be less than or equal to 0, right here. Okay, less than or equal to 0. So here we go. Negative infinity to negative 1. Do I close it at the 1? At the negative 1? And then 2 to 5? Both? For the 2 and close the 5. This is amazing. Isn't this amazing? Yeah. This is amazing. I know. It is kind of awesome. Okay. So